a quick review, and it's mostly going to be voice. So it's a review of the gas laws and kinetics. Okay, so here we go. Ideal. I want you to try and do it without. Just tell me real quick. Ideal law. Pervert. PV equals nRT. Right? Ideally, you're not a pervert. Pervert. Okay? P has to be in what? Units. ATM. Volume has to be in? Liters. Good. N is what? Number of moles. R is what? That's the set one. It's always the same. Close. 0.0821 atmospheres times liters divided by mole Kelvin. And then temperature always in all the gas laws has to be what? Kelvin. How do I get Kelvin from Celsius? At 273.15. Okay. All right. If I hold volume constant, whose law? Volume constant. Boyle's law. Yeah, Boyle's law. Because temperature held constant. What is Boyle's law? Has to. Okay. No, sorry. Yeah. What did I say? Temperature held constant. It has to be. Oh, sorry. If volume's held constant, it's not Boyle's law. It's. Gay-Lussac's. Okay. So, and if I've got this PTV, if I've written the PTV and I'm holding volume constant, then the law has to be with the other two. Temperature's always on the bottom. So it's P1 divided by T1 equals P2 divided by T2. Good. So if I hold temperature constant, then we have Boyle's law. And so Boyle's law is what? T is the only one on the bottom. P1 times V1 equals P2 times V2. Okay, if I hold pressure constant, whose law? Charles, because he's under lots of pressure, right? And my law would be what? It is V1 divided by T1 equals V2 divided by T2. Okay, what is the law that includes all of these? On one side and all of them on the other side. It's the one that we take. No, it's the one where we take perv nert and we set it equal to R. So we get R equals P1 V1 divided by N1 T1, but we don't usually put N in there. And we set it equal to P2 V2 divided by T2, and it could have N2 in there, but we usually don't put that there. What was that law called? It's the combined gas law. That was pretty, we combine them all.
We remembered all, the last.
I know. Okay, you did all the great ones. Okay, now there's two other laws that don't have anything to do with perv nert. What were they? Dalton's law, which was what? All the little pressures added up equal the total one, right? And we usually use it how in lab? So we usually catch gas by bubbling it through water. So if we have the pressure in the room, that's the total pressure. But I've got to take away the water pressure to get the gas pressure, right? So pressure total minus the water pressure gives me the gas pressure. And I usually have to take and look at a table of water temperatures to get the water pressure. Okay, that's a hint. It's in your first assignment. Okay, so we got that one. And then we got the stink bug one. The diffusion of gases. So which one's that called? The way I remember it is Grandma's perfume. It's Graham's law. Okay, so Graham's law, and that was the kinetic energy one. So that one was rate A divided by rate B. Let me just put it up here because it's hard to say. So rate A divided by rate B equals the square root of the molecular mass of B divided by the molecular mass of A. Okay, and that has to do with rate. Now, same words, rate, speed, velocity, those all mean the same thing. Okay, so if they say anything like that on a problem, you know you've got grams. All right, now, ideal gas laws, kinetic theory. Yeah, toddlers. There's 5 of them. Remember them? So elastic collisions, okay? Don't attract or repel. The blanket one. What was the blanket one? When it's cold, it slows down. So kinetic energy is directly related to temperature. So when it's cold, it slows down. When it's hot, it speeds up. Okay?
Oh yeah, I know that. The blanket
And what? Squirrel. Random straight line motion. Okay, squirrel. And one other. The most obvious. Toddlers are small. They're so small, they're almost no volume, right? Because they can sit on your lap. Okay, so okay, that was the ideal gases, but get real, we're teenagers. What changed?
we have volume now.
We have volume, we have attraction and repelling, and non-elastic collisions. We've been to driver's ed. Okay, right? Yeah. Okay, so I want these real gases to now be more ideal. Summer rules. No pressure, because I can okay, no pressure. Sorry, I almost gave you another one. Hot temperatures or high temperatures. What's the other thing? Summertime rules. No, I wish that was true, but no. I can hang with who I want, right? Non-polar situations. I don't have to be in a class with people I don't really like, or in a class with somebody I really, really, really like, but they don't like me. Okay?
That's really awkward.
That is awkward. Okay, so we've reviewed really quickly what we did last time. Okay, so what I want to do this time is I want to work on daily work 1, daily work 2, and your review. That's what you're doing today. Next time when you come, we're going to have a little quiz on these gas laws, okay, and the kinetics. So don't forget them because you remembered them right now. Don't forget them. Also on your daily work 1, if you'll get that out real quick, I was messing with the water table and I took out one of the lines for the kinetics down at the bottom right there on that page right there. Yep, right above the table. There should be a line, another line 3. There's only 1 and 2. So just cut 2 in half and make a 3 because there should be three things. Okay. And then the other thing that I wanted to tell you, we are going to correct 1 and 2 daily work next time. So make sure they're done. So if you get done with daily work 1 and 2, like a lot of them did, start working on your review because we have got to get that review going. Now, with the SAGE test, let me tell you what's going on with that. Some people have opted out, and that's fine. You will be taking my test. Those that are taking the SAGE test, if you get a 3, you don't have to take my test. That tells me you're competent, you know your stuff. My test is to see if you're competent, if you made it through the year. Okay? If you didn't get or don't get a 3, and you'll be able to tell right when you finish if you get it or not. Okay? If you don't get a 3, then you take my test the next time. Okay? And my test is one of those questions for each of the core standards. So the takeaways, if you didn't get one, they're back in the back of the Gen Chem box. I will be looking at one question for each takeaway. Okay? I want to know where you're not getting it. If you don't get a 70 or above on my test, then I'm going to pull you aside and say, okay, this is where you don't get it. I'm going to reteach you, and you can retake it again. Okay? I want you to pass. I want you to have a competency level of 70 or above. Okay? And we'll keep doing that until, hopefully, either the end of school comes or you make that competency. And I really want you to make that competency. Okay? Yes, ma'am.
So would the SAGE just be participation and your test be on a grade?
They'll both be participation. Okay? So they'll both be participation because I can't hold the SAGE as a grade. But I want, well, let me put it this way. The SAGE is a participation, but you opt out of my test. So the test, my test, is a test. Does that make sense? So if you get a 3 on a SAGE, you get 100% of my test. because you've already showed me that you know it, right? So why do I have you take another test? Does that make sense?
Are we allowed to like use like the one?
3x5 card? No. Okay. Yes.
So is 3 like highest you can get?
No. Four is the highest. Three just means competent. Three means competent. 2 means almost there. 1 means you have no clue. Okay. So those are the 4. There's 4 levels. I wish they would do it out of 5 and a 0, because that would make more sense. Because middle would be, but they rated out of 4. Then you get to take my test, because I want to see what it is for me is it's actually a help for me too, because it tells me where I was weak in teaching you. So then I can pull you aside. If everybody gets the same weakness, does that make sense? Then I know where I need to fix for next year, and I can reteach you and have you make sure that you knew the stuff before you leave me. Does that make sense? Okay, so it's a test on my grade, but it's not necessarily reflected of the SAGE. Does that make sense? You get opted out of my test if you pass the SAGE with a 3, but if you didn't pass it with a 3, then I want to see where you were having problems. And then you get to retake it until hopefully you get it. Does that make sense? So it's different than a normal test, but it's going to go on your grade as a test. So if you get a 4, I might give well, I can't give extra credit. So I might see if I can find an incentive for you if you get a 4. Okay? But the incentive basically is you don't have to take my test. You have to take another test. Yeah, that's a good incentive though, right? Yeah, but if you get a 4, I might, okay, I'll think about it. I do an end of the year award for my best kids. Okay?
Review by ourselves.
Okay, so what we're going to do is next time we'll do nuclear, first nuclear. The next time we'll do half-life nuclear, and we'll start a review again. So the reviews I've been giving you, after every test, that's a review of the year. So I'm trying to get you back into, okay, remember what we did at the first of the year. Remember what we did the first year. I'm going to be giving you another one, and we'll have a whole day on that review. So if there's something you don't get before we hit the SAGE, I hope you'll have time to ask. Okay, does that make sense? Yes. I don't know. I lost my password. I'm waiting for them to give me my password back. Mine is basically one question for each thing on the SAGE. I did test also like chemical and physical, if you knew what the difference was at, if you knew how to do scientific notation, and if you knew how to do significant figures. So I did add those to what's on the core test. Yeah, that's it right there. The SAGE is supposed to test the state core. That's what I'm doing with my test. I want to know, did you learn what you were supposed to learn during my class? Okay, so the bonus is on the SAGE, if you take it and you get 3, you don't have to take mine because I know you know it. But if you don't take the SAGE or you didn't get a 2, I want to know what you did, where was your problem? And then I want to reteach and make sure that when you leave me, you've got it. Okay? Yes?
What resources are we going to have on the SAGE?
You will have a periodic table like the laminated one I've been giving you. You will have an online calculator. That's have to punch, it's sort of, yeah, it's a longer time. No, we have fought for that, Ian. We have really fought for that. And they said, no, 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 no. And we're like, come on, AP lets them use their calculators. The ones they're used to. Why do we have to use, anyway. I've been there, fought that battle, lost several times. But I'm still fighting because I think it's stupid. Okay? But I want you to know what was coming up. So if you don't, so what the day after we finish the SAGE, then we're going to do my test. And then after my test, we start presentations. So I might actually be moving you and Thomas and Peyton back a day because I need those 2 days for the test. Does that make sense? So you might, I'm going to be moving you guys into here. So I need to know if any of you are planning on taking more than a half hour. Okay? Because if you are, then I need to make sure they're not on that day. Does that make sense? So I can get 3 in a day. So there is going to be a little bit of adjustment with yours. Okay? So earliest you'll be is a Wednesday now instead of Monday, which will be nice because I can remind you. Okay? All right, any questions? If you need a calculator, there's over by the flag. And let's work. Let's get this done.
You got that daily work last time?
Mm-hmm. It should be in the Gen Chem thing, yeah. Yeah, you bet. Okay, so number 2, the gas laws, what did we get so far? Okay, the formula was Gay-Lussac's, right? Oh, that's V1, okay. And what is Kelvin or temp or Celsius? T2? 408.43. Okay, pressure? mmHg. And you're looking for P2. Okay, this is the volume of our little car. Okay, volume of a car doesn't change. That's how we got Gay-Lussac's. Okay, because the volume didn't change. I can't change the interior volume of a car. It's just going to stay. Okay, so we've got this. Gay-Lussac's is the P1, T1 equals P2, T2. I think they're all easy. So we are solving for this one, right? So we can rearrange it right now, or we can just plug in and solve for what we have. You want to just plug in? Okay. So over here in work, we're going to plug in. So 730 millimeters mercury. No, the only time, good question. Only time it has to be ATM if I'm in ideal. Ideal has to be specific units. If you're given moles, you know you're going to use ideal because the others, the moles drop out. Okay, so in ideal, you have to be in atmospheres and liters and moles, and you have to be in Kelvin. All the gas laws with temperature, you have to be in Kelvin. Okay? No. Okay, so here's your first temperature, and it's equal to P2 divided by your second temperature. Now go ahead and divide this through. Somebody give me an answer there. You can take it step by step. So this is number 2 on your daily work, day 1. So you should be following us through unless you're ahead of us. Give me a couple more. 5, 7, okay. Then all we have to do is times both sides by 408.43. Over here it cancels out, and we get P2 is equal to what? Okay, and that is millimeters mercury, but we go back and we're looking and we have only 2 sig figs. So we need to go back and fix this so it's just 2 sig figs. To do that, that means I'm only going to report these 2, but this one is a 0 because this doesn't round up. So I have to put it in scientific notation, which is this, and this is what I would report as my answer. Okay? Any other questions with that? Okay, so what I'm going to do is, let's go ahead and go forward to number 8, because that is the one that everybody gets stuck on. Number 8 on day 1. And since everybody gets stuck on it, let me go through it with you together. Number 8 has to do with our mole map. Okay, so you've been given an equation. That's a hint to use the mole map. You're going to use the part going up and down. 22.4 liters is equal to 1 mole going up and down. And that can only be used, you'll notice, at STP. Well, that's what the problem says. It's at STP, right? And it gave me a volume. It was 35 point what? Liters of what? An excess hydrogen. And the equation that we used was H2 plus O2 yields H2O, right? Right, I have to go back and balance. I couldn't remember the balancing until after. Okay, so now what we want to do is we know how to do stoichiometry, right? But we've got to be in moles. So first thing we need to do is get liters into moles. And since it was at STP, we can use 1 mole is equal to 22.4 liters. So that's what we do right here. 22.4 liters of O2 is equal to 1 mole of O2. So the liters of O2 will go out. What am I trying to get to, by the way? What is it asking me for? Oh, so I'm looking for how many liters of water. Okay, so then I want to go from here to here using the coefficients. So for every 1 mole of O2, I get 2 moles of water, right? So now I can get rid of the moles of O2, and I can go on. Okay, so now I'm in moles of O2, but it wants liters. So then I got to use that conversion again to go down. So in 1 mole of water, there's 22.4 liters of water. So here I can cancel out moles, and I can cancel out 22.4. The liters will still stay. So basically I'm just taking this, timesing it by 2, and I've got my answer. Now, this only works because I'm going from liters to liters. A lot of times we go from grams to liters, or liters to grams. 71.53, give me one more. 0. Liters H2O. Because I need 5 sig figs. Sorry, I went fat on the end. Okay, so this would be my answer that I would report down. Right? And now I want to give you one more hint, so turn the page one more time. Remember at 11 to add a number 3, so and I would just cut that 2 in half and just put a 3 off to the side so you can cut it vertically or horizontally, I don't care. That next table right there has to do with number 12. So in number 12, it's a duh law. I'm giving you all a hint. It's a duh law. Okay? So you use Dalton's duh law. And the temperature just tells you how to figure out the pressure of the water. Okay? So you're going to use the table to find the pressure of the water. All right, so what I'm going to do is I'm going to wander around, give you help as you need it, work on daily work 1. Daily work 2, by the way, has answers down at the bottom. The units might not be where they're supposed to be, but I'll tell you that with one of them. It's supposed to be a Kelvin temperature or Celsius temperature, and I put a different thing there. But the numbers are right, okay? The units might not be. Any questions? Okay, so if you finish daily work 1 and 2, you go right on to your review. If there's anything you haven't handed in, make sure you get it in ASAP. Remember, you've got 3 grace cards. After the 3 grace cards, things that you hand in late are half off. Yes? Okay, let me go ahead and stop this and then I'll go back.